Hello, in this video, we're going to be looking at lesson 10.4, day 1, on the surface area of prisms. The day 2 video will look at how to calculate the surface area of cylinders. Let's start with some vocabulary related to the surface area of prisms. First, the bases of a prism are the two congruent sides that are parallel to each other. It's important to remember that the bases are not always the bottom of the figure. Sometimes they are, but they don't have to be the bottom of the figure. For example, in this picture right here, the base is the hexagon, but in the other prism right here, the base is a triangle. And notice that that triangle is not on the bottom. The base can be any polygon. The lateral faces are the sides of the prism that are not the bases, and those are always going to have 4 sides. So if any face does not have 4 sides, that automatically makes it the base. Next, we have lateral edges, and the lateral edges are an edge that is not an edge of the base. So you can see in the diagram here, the lateral edges are labeled. So this is an example of a lateral edge right here and there. In this class, we're mainly going to be dealing with right prisms. A right prism is a prism where the lateral faces are all rectangles. An oblique prism is a prism where at least one of the lateral faces is not a rectangle. You can see some diagrams right here. This is a right prism. This is the type that we'll work with the most. Notice that the bases are parallel to each other, and the sides that are not the bases, the lateral faces, are rectangles by these 2 right angles. This one over here is also a triangular prism. The bases are still parallel and congruent to each other, but you'll notice that the lateral faces are not rectangles. The height of a prism or a cylinder is the perpendicular distance between the 2 congruent and parallel bases. So depending on, how your prism is standing, the height in this case, like the one in my picture here, this is not in your notes packet, but the height would be right there. But if my prism were laying like on its side, so I'm going to draw this triangular prism here. Well, now the height would be right there because the height is the distance between the 2 congruent bases. It's not always from the bottom to the top. It's only from the bottom to the top if the bases are at the bottom and the top of your figure. The lateral area is the sum of the area of all the lateral faces. So that would be all of the faces that are not the base. So in this picture right here of this hexagonal prism, the lateral area is going to be the area of these 6 rectangles that connect the bases together. So the lateral area would be this piece here that I just outlined in blue. The surface area is the sum of the lateral area and the area of the 2 bases. So we do the area of the lateral faces plus the area of this base and this base. Let's see if we can notice a pattern for the lateral area and the surface area. Notice that the lateral area of a prism is just one big rectangle. The height of that rectangle is the same as the height of the prism right here. And then the length of the rectangle, it's these 6 sides added together. So since this is a regular hexagon, all 6 sides are S, so it's 6S. Also notice that that is the perimeter of the base. The perimeter of the base is 6 times S. So the lateral area is going to be calculated by taking the perimeter of the base times the height. And then for the surface area, all we have to do is take the lateral area and then add in the area of the 2 congruent and parallel bases. So in my example on this slide here, the bases are hexagons. So I'll call that a base and that a base. If we add the 2 bases together, we then have the surface area. So that brings us to the formulas for calculating lateral area and surface area. To calculate the lateral area of a right prism, the formula is lateral area is equal to PH, where that capital P is the perimeter of the base and the height, H, is the height of the prism, or the distance between the two bases. That's what the height is. So LA equals P times H. The surface area is just the lateral area plus 2 times the area of the base, since there are two congruent bases. In order to calculate the area of the base, you'll need to pick the appropriate area formula that we learned back in Unit 9. For prisms, the bases in this class are going to be either rectangles, triangles, or regular polygons. You can also write the surface area formula like this, where instead of LA plus 2B, you substitute in the P times H for the lateral area, plus 2 capital B. So with these formulas in mind, let's go ahead and try an example. The first thing we need to do is figure out what the base is. And you'll notice in this prism here, there's a triangle right here, and there would be another triangle back in the back. Okay, the base is the triangle. If any face is not a rectangle or does not have 4 sides, that's automatically your base. So when I do the lateral area, LA equals P times H, we need to make sure that we find the perimeter of the base. And again, the base is not always the bottom. In this case, my base is this triangle right here. So for the perimeter of the base, we'll just add together the sides, 17 plus 17 plus 16, and that adds to 50. So perimeter is 50, and then our height is the distance between the two bases. So that 11 right there is the height of the prism. And now we have everything we need to calculate the lateral area. The lateral area formula is LA equals the perimeter of the base times the height, and the perimeter of the base is 50, the height is 11, and 50 times 11 is 550. This is an area, so the unit would be 550 meters squared. That value accounts for the area of the rectangular faces, and here there are 3 rectangular faces. The combined area there would be 550 meters squared. If we want to find the full surface area, we next need to calculate the area of the base. And this is probably the step that's easiest to mess up, because for the area of the base, you need to make sure you are only looking at the 2D figure. So the height of the base might be different than the height of the prism, and in this case, it very much is. Now, the base is a triangle, and if you go back to your formulas for the areas of triangles from Unit 9, we know that the area of a triangle is base times height divided by 2. Okay, I have to very carefully make sure that I am just looking at the triangle. So I'm going to draw the triangle right here. It's outlined in blue up there. And you'll notice that this is 16, and then there's this dotted line in the middle. That's the height, that's 15. The 17s on the sides are not needed for our area formula. The area is just base times height. Okay, so the base of our triangle is 16, the height is 15, and then I'm going to divide that by 2. So we'll grab a calculator, take 16 times 15, that's 240, divide it by 2, and 240 divided by 2 is 120. So the area of the triangular base is 120 square meters. Now we have everything we need to calculate the surface area. The surface area is just the lateral area plus 2 times capital B, where capital B is the area of the base that we just calculated right here. So let's take 550 plus 2 times 120, and you can type that whole thing in your calculator, or you can do the 2 times 120, 240, and then add 550 plus 240 to get 790. And that'll be the surface area, 790 square meters. So that is the area of the lateral faces plus the area of the base. The lateral area that we calculated in step 1 did not include the two triangular bases. The surface area includes the triangular bases, so your surface area will always be larger than your lateral area. Let's try another example here. This time we have a rectangular prism, and technically for a rectangular prism, since all sides are rectangles, we could really pick any side to be the base. This problem says to use the rectangle with the 4 right angles as the base. So I'm going to outline that here in green. So my base is a rectangle, and in that rectangle, let's start with the perimeter. Notice that the two sides of the rectangle are 7, and all of the sides are going to be 7 then because our opposites are equal. So for the perimeter, it's going to be 4 times 7, which is 28. The height is the distance between the two bases. So if we're using the base at the bottom, the height is going to be the distance between the base at the bottom and the congruent base at the top. So this 5 right there is the height of the prism. And now we have everything we need to calculate the lateral area. LA equals the perimeter of the base times the height. So we just need to take 28 times 5, and that's 140. So 140 square yards for the lateral area. Next up, let's find the area of the base. Here, the base was a rectangle. Technically, it's a square, but the same formula for rectangles and squares. Area is just base times height. And remember here, the base and the height, I am only looking at the two-dimensional rectangular base. So the height is going to be different than the height of the prism that we used in step 1. Looking strictly at the base, you can see that it's just 7 by 7. And if we take 7 times 7, that is 49. So the value for the area of the base, the capital B in our formula, is equal to 49 square yards. Now we have everything we need to calculate the surface area. The surface area is just the lateral area we calculated in step 1 plus 2 times the area of the base that we just calculated in step 2. So let's do 140 plus 2 times 49. And you can actually just type that whole thing into your calculator and it will give you 238. So the surface area then is 238 square yards. Here's one final example. We have a prism this time, and you can see that the prism has a hexagon base. So it's always important before you start a surface area, lateral area problem that you identify the base. So for the perimeter of the base, I'm looking at the hexagon right here, and you can see that all 6 sides are congruent. So if each side is 9, we can just take 6 times 9, and that's 54. The height of the prism is the distance between the two bases, and you can see that that right there is 12. So to calculate our lateral area, we now have everything we need. LA equals P times H. So just grab your calculator and take 54 times 12. And that will be 648 inches squared. So there's our lateral area. Now let's move on to calculating the area of the base. The area of the base, we have to identify the base is a hexagon, which means it's a regular polygon. And if we go back to our formulas for the area of a regular polygon from Unit 9, the area formula for a regular polygon is area equals the apothem times the perimeter divided by 2. Now, the apothem is that 7.8 inches from the center of the hexagon to the side of the hexagon where it makes that 90. So I have 7.8. We already calculated the perimeter here in step 1. So 7.8 times 54, and then we'll divide that by 2. First, type 7.8 times 54 into your calculator, and when you do that, you get 421.2. Then click divide by 2, and it'll give you the area of the base. So the capital B is 210.6, and it would be inches squared. And now that we have that, we can finish up with our surface area. The surface area is the lateral area plus 2 times the area of our base. The LA from step 1 is 648 plus 2 times that capital B, so 2 times 210.6. We can then just type that whole expression right into our calculator, and when we do that, we'll get 1069.2. So our surface area is 1069.2 square inches. And this concludes day 1 of lesson 10.4. In the day 2 video, we'll talk about how to find the surface area of cylinders. Thanks for watching. Bye.